Hi guys, we're going to have a look at another question now, where instead of wanting the whole expansion, which, you know, if you've got a binomial to the power of 20 or something, that's an awful lot of terms. This time, what if you're only after one particular term? So let's say we had a binomial, let's see, 1 over x plus x squared, going a little bit harder this time, to the power 15. So the first thing I want to have a look at, there are 15 terms, up to the power 15. How many terms are there? Remember, there is 15 plus 1 terms. So whatever the power is, we know there's one more term. So we know there's 16 terms. I don't know about you, I don't know whether I want to have to expand the whole lot of those 16 terms out just to find a particular one. Okay, so let's say I want to find the constant term. What do we mean by constant term, do you think? Okay, it's the term with just a number in it. But if you have a look here, we both have terms with variables in it. So what do you think the constant term might look like in this situation? Well, if we're talking about variables, you may want to think about x to the 0. If we have x to the power of 0, we do know we have a constant term there. Okay, so we're going to focus on this idea of needing to get x to the 0. All right, so let's start expanding this. Now, you know, we're trying to look for strategies, and we're going to have a look at a few. You know, some intuitive, some that's a little bit more formal, based around formula. You know, you have your own choice there. So let's start with this one. All right, we know we've got 15 terms. Now, because I have to figure out which term I'm looking at, and this is going to be the key thing, I'm not going to worry about fleshing out all the different details, like all the coefficients and stuff. We're just going to focus on trying to figure out which term the constant term is going to be. All right, so the first term we know is going to be this to the power 15. So we've got 1 over x to the power 15. Of course, we have a coefficient there. I'm just going to leave that there. Let's call it a c, coefficient. But we're not going to worry about figuring those out until we know which term we're dealing with. All right, and we'd have x squared to the 0, so we don't need to put that one. All right, then next term we're going to have another coefficient, 1 over x to the power 14, x squared to the power 1. Then another coefficient, whatever that comes out to be, 1 over x to the 14, x squared to the, 13, going down by 1s, x squared to the 2. Remember, our exponents have to add together to give 15 all the time. Plus 1 over x, what are we up to? 12, x squared, 3. Oh, as you can see, I'm tired of doing this already. 1 over x to the 11, x squared to 3. I want you, while I'm doing this, I want you to be thinking when to yell out, "Stop, Miss Makunja," when you can see perhaps where this is going to be the case. Okay? Plus some coefficient, 1 over x to the 10, x squared to the power 5, plus some coefficient, 1 over x to the 9, times x squared to the power 4, plus, all right, I'm really tired of this already. And if you haven't yelled out "stop" already, you need to have another look. All right, come over here and have a look at the terms. You can see which one of these terms is going to give us the x squared to the 0. All right, let's consider this term here. This one's going to be a 1 over x to the 14 times x squared. Well, with a little bit of algebra there, we're going to get 1 over x to the 12. Yeah, definitely not a constant term, definitely not an x to the 0. Come up here a little bit. We'll have here 1 over x to the 12 times x, using exponent laws, x to the 6. Well, we've got 1 over x to the 6 there. Well, have a look. We've got the denominator here of 12, x to the 12. Here's denominator x to the 6. It looks like we're moving in the right direction. All right, if you can see it over here, have a look at this little fella here. What is this term going to be? That's going to be 1 over x to the 10 times, exponent laws, x to the 10. Well, hello, have a look at that. Those x to the 10s are going to cancel out, giving us x to the 0, aren't they? So this is our constant term, which happens to be the first, second, third, fourth, fifth. The sixth term because we know it's this number plus 1. All right, so now we've figured out what term. All we've got to do now is get the coefficient. So we're going to have, what is it? We've got 15. I'm going to write it the different way. 15, choose, what have we got? 0, 1, 2, 3, 4 to the 15, choose 5. All right, there we go. And when we do 15, choose 5, we end up with 3003. The x to the 10s cancel out. So there is our constant term. Okay, so that's one way of looking at it. Now, there's another way. I don't want to have to go and do all this. But some of you may have been able to think here a little bit quicker than having to write out all of those. So let's have a look and see what that looks like a little bit. So let me scroll down a bit. All right, let's just come back over to it. We had, so we're going to explore the thinking. We had 1 over x plus x squared to the power 15. Okay, so if we go back to that idea of understanding we want to get an x to the 0, we have 1 over x to something times x squared to something, and we know when we multiply those two, we need to get x to the 0, don't we? Okay, now if we think about this a little bit, that's x to the minus 1. So we've got x to the minus a times x to the 2b has to equal x to the 0. Well, what do we know about our exponents here then? What do we know about that? We know when we multiply with the same base, we add those. So we've got 2a minus b has to equal 0. Or 2a equals b. Also, what else do we know about a and b? A and b have to add together to give 15, don't they? So we know a plus b has to equal 15. Well, you do have a set of equations there you could figure it out, or just by intuition there. Straight away, should be able to figure out, well, if a is equal to 5, b equals 10, 5 plus 10, 15. There we go. A equals 5, b equals 10. So now we can come and figure out our term. So our term then is, we have 1 over x 1 over x to the power of, oh, have I got those the wrong way around? Let me just go back here. I put the wrong thing there. That's 2b minus a. So 2b is equal to a. Sorry. A is equal to 10. B is equal to 5. So we're going to have then 1 over x to the power of 10 times x squared to the power of 5. Now, how do we figure out this coefficient here? We know it's going to be 15. Choose, it's this number here, isn't it? R. 15, choose 5. And of course, just to add on, we know that this is term, if R is equal to 5, we know that that is term 6, one more than that. So when we get that, we know we're going to cancel those out, and we get our 3003. So that's perhaps a way you can show your thinking that saves a little bit of the tedious writing out. Now we're going to have a look at a way some of you like to think a little bit more formally. So we're going to go back to our definition that if we have a plus b to the n, we know that t of r plus 1, in our case we've got 15cr, 1 over x to the 15 minus r, and x squared to the r. Now, This is a little bit more formal because we know if r equals 5, and we know this, we just found it, if r equals 5, we know we've got term 5 plus 1, term 6. Okay, so what can we do to figure these out? Once again, we don't really need this at this point. We really need to focus on this to work out what our value of r is. Okay, so once again, rearranging here, we've got x to the minus 1 times 15 minus r times x to the 2r. And we know that has to equal x to the 0 because we're after the constant term. Got to keep remembering what we're after here. This little fellow is our constant term. All right. So let's do a little bit of math. We have x to the, it's going to give us r minus 15 times x to the 2r equals 0. Same base, we can add. So we've got 3r minus 15, and that has to equal 0. We can see pretty closely, r comes out to be 5. Now, how does that help us in our search for the constant term? Well, let's go back up here. We can now put our r back into here. So we have term 5 plus 1. We know it's the 6th term. We've got 15, choose 5. I'm just changing my notation again, just to mix it up a bit. And we have got 1 over x to the 15 minus 5. There's our 10 that's coming out. And there is our x squared to the power 5. 15, choose 5, remember. 3003. We get 1 over x to the 10, our x to the 10. They cancel out. And there is term 6, which is our constant term of 3003.